Welcome to our lesson 4. This time round we are going to concentrate on refractive index. Okay? In our previous lesson we looked at the two aspects of laws of refraction. That the incident ray, the normal, and the refracted ray at the point of incidence, they make one plane. Okay? Then the second aspect was studied by Snell's, and he said the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. That constant is also known as refractive index. So today we are going to look at it maybe in more detail. You can see now lesson 4, refractive index, which is denoted by letter nu. Okay? So I have a diagram here showing us two media, 1 and 2. So those are two different media. Okay? A ray is traveling from media 1 towards media 2. You can see the arrows. So by that definition of refractive index, you put subscript 1 where it is coming from, then subscript 2 where the ray is moving to. So when I have 1 and 2, it means refractive index of medium 2 with respect to 1. Coming from 1 going to 2. You get the sine of angle I. So angle I, remember, it is the angle made by the incident and the normal. So just to change things a bit, I've put it letter X. That X is I, incident angle. And the refraction, the angle of refraction is the angle between the refracted ray and the normal. So denoted by Y here. So this is what will give me refractive index of glass with respect to air, or of water with respect to air. Number 1 is where the ray is coming from. Number 2 is where it is going. So this would be our expression for refractive index. Now, if we look at diagram 2 here, the second part, see, I've reversed the arrows. The arrow have been reversed. So what do we need to understand here this time round? The ray is moving from medium 2 towards 1. So our angle of incidence is in the medium where the ray is coming from. So in this case, Y. This would be our angle of incident by virtue of having incident ray. Okay? If I put here, this is our incident ray. So incident ray and normal gives you angle of incidence. In our case, Y. And then you go to the medium 1 where the ray is traveling to. Okay? That is medium 1 now. So remember, it is from 2 to 1. You can see the arrows from 2 to 1. So refractive index is sine I over sine R. So our angle of refraction is made by refracted ray and the normal. Refracted ray and the normal. So it is denoted by X. So this would be our expression for refractive index as the ray moves from second medium to first medium. But I want us now to draw our attention down here. Let me focus the camera down a bit. There, I think we are able to get, especially this part, with respect to this. I've just picked this and written it here now. Okay, 2n1 is equal to, if I write 1 over this expression now, okay, see that 1 over this, it gives me sin y in the numerator. So I want you to understand this part. This is a simple mathematical maneuver. 1 over this, okay, this here, 1 over this gives me that, okay, but this denominator is the same as 1 and 2, okay, 1 and 2, this is that. It's like if you have 1 over 2 over 5. It's the same as 5 over 2. Okay? So, we are getting a relationship here. 1 over this gives me this fraction. And this is the original way of doing refraction, refractive index. So you have essentially this can be written as that. Therefore, in conclusion, n2 and 1 is equal to 1 over 1 and 2. Okay? Is a relationship that you have to build. You start here, you come here. By definition of refractive index. This is by definition of refractive index. From medium 1 to medium 2. Here from medium 2 to medium 1. Then we want to see the relationship. We come here. That this can be found, this part can be found as a reciprocal of this. Okay? That's why we are saying reciprocal of this. This in the denominator now. If you multiply, you find that y goes up, x remains down. But this expression, sin x over sin y, is also known as 1 and 2. 1 and 2. So a relationship now is built between this and that, which is down here, and this is here. Okay? So let us just look at a simple example. Refractive index from air to glass is 1.5. Refractive index from air to glass is 1.5. Okay? So we are given, maybe I put from air to glass is equal to 1.5. Find the refractive index from glass to air. We are asked refractive index from glass to air. What will it be? So this is where you use this idea. Glass to air. It's like 2 to 1. So it means we are going to get 1 over what we are given. We have been given 1 to 2. So we are given 1.5. We are given 1 to 2. 1 to 2 is 1.5. But we have a relationship here. When you want the reverse, you take the reciprocal of the previous. Okay? So you will get your answer using such simple method. So next lesson we shall introduce 2 more so that you start getting, this is formula number 1, very important. Formula number 2, this is formula number 3, which relates 1 and 2. So that you know from one medium to medium 2, and what happens from medium 2 to medium 1, and what relates them. So we are going to have a lesson to introduce 2 more formula, and then we shall do some practice now, the application. When you are given this, what happens? Please subscribe, you will get more, especially the next lesson. Bye bye. For now, wait for lesson 5. More formula, more explanation, physics made simple. See you. Bye bye.